Alright, so to solve a triangle, means to find the lengths of all of its sides and the measure of all of its angles. So if we are asked to solve a triangle, what it's really asking us to do is to find the measure of all the sides of the triangle and of all of the angles in the triangle. There's a couple of theorems that we're probably familiar with, but let's mention them. And the first one has to do with the sum of the angles of a triangle. So the sum of the interior angles of a triangle with angles alpha, beta, and gamma is alpha plus beta plus gamma has to equal 180 degrees. So that is that the sum of all of the interior angles of a triangle always add up to 180 degrees. Then we have a corollary. Let's spell that correctly though. Corollary. Oh, that's twice. Alright. There we go. Corollary. If a triangle is a right triangle, then the sum of the two non-right angles is 90 degrees. So basically, if we know one of the angles has to be 90 degrees, then the other two also have to add up to 90 degrees. Alright, let's go ahead and take a look at our first example. If we were just told to solve, so remember, to solve a triangle means to find all of its angles and all of the measures of all of its sides. So if we were just asked to solve and we were given a triangle with the following information, we know that this angle is 47.4 degrees. We know that this side is 31. And we know that this is a right angle. We need to solve this triangle. Well, since we know it's a right triangle, let's go ahead and label what we're trying to find. I don't know this angle, so I'll call that theta. I don't know the hypotenuse, so I'll call that C. And I don't know this leg over here, and I'm going to call that one B. Well, if we're trying to find the angle theta, we know that theta, from our corollary above, plus 47.4 degrees has to equal to 90 degrees. So if we minus 47.4 degrees, we get 90 take away 47.4 degrees gives us 42.6 degrees. So then that gives us this. So now we just need to find B and C. Well, I know the angle 47.4 degrees. B is opposite of that and 31 is adjacent. So then we can use opposite and adjacent are the tangent function. So the tangent of 47.4 degrees has to equal our opposite, which is B, divided by adjacent, which is 31. Solving that equation for B gives B equals 31 times the tangent of 47.4 degrees. So we grab our calculator once again, and we have 31 times the tangent of 47.4. And we get this value. And since all of our original data was given to 1 decimal place of accuracy, we should report all of this to 1 decimal place worth of accuracy as well. So we get that our value for B is approximately 33.7. And then lastly, we now need C. So I still know my adjacent and I want hypotenuse. So adjacent and hypotenuse are related by the trigonometric function cosine. So then the cosine of 47.4 degrees is equal to adjacent over hypotenuse, so 31 over our hypotenuse C. If I solve this for C, that gives me C is equal to 31 over the cosine of 47.4 degrees. Once again, that's calculator food, so 31 over the cosine of 47.4, and press enter. Rounding to 1 decimal point again, we get this time that it's going to be 45.8 is going to be our length. So we get C is about 45.8. All right. So solving a triangle, remember, is finding all of the sides and all of the angles, which is exactly what we did. So when we're asked to solve, we need to use our trigonometric ratios. Sometimes you may need to use the Pythagorean theorem, as we did in the previous section, and that's okay too. All right, so now let's take a look at the examples that are on our handout for this section. So the very first one on our handout reads as follows. From the top of a lighthouse, the angle of depression to a boat is about 10 degrees. If the lighthouse is 185 feet tall, how far is the boat from the lighthouse? So let's draw our sketch. So here's my lighthouse, and we know that it is 185 feet. And then we have our water down here. We have our boat down here, and we're told that looking down from the top of the lighthouse, that the angle of depression is about 10 degrees. So that means it's going to be this angle. So remember, when we were talking about this in the previous section, The angle of depression is the positive angle as measured from the horizontal, but remember, it is equal to, by the fact that we have a transversal of two parallel lines, the angle of elevation from the boat by opposite interior angles. So coming back to our diagram that we're drawing here, if that angle is 10 degrees, then this angle must also be 10 degrees. So we now want to know this, so let's call this D, and that's what we want. So we have our angle 10 degrees, we have opposite, and we have adjacent. So then that tells us that the tangent of 10 degrees is equal to opposite 185 over adjacent, which is D. Solving for our distance, we get 185 divided by the tangent of 10 degrees. And we'll put that into our calculator. So 185 over the tangent of 10 degrees gives us 1,049 for our solution. So it appears that the boat would be about 1,050 feet-ish. 1,049 or so feet from the lighthouse. All right, let's take a look at our next one. Example 2. So a window washer on a ladder looks at a building that is 100 feet away. The angle of elevation to the top of the building is 18.7 degrees, and the angle of depression to the base of the building is 6.5 degrees. How tall is the building? All right, so we've got some building over here. We have a window washer hanging out here, and then we have another building over here. And we're told that the distance between the buildings is 100 feet. We're also told that the angle of elevation to the top of the building is 18.7 degrees, and that the angle of depression to the bottom of the building is 6.5 degrees. We want the height of the building. Well, what's going to make this a little bit more complicated is we have our distances here, D1, and then we have this distance from the horizontal, D2. The height of the building is going to be both of those, or the sum of those. It's going to be D1 plus D2. So in each of these cases, what do we know again? We know adjacent, and we want opposite. So we get the following equation for D1. We have that the tangent of 18.7 degrees is equal to D1 over 100. And we also have that the tangent of 6.5 degrees is going to be equal to D2 over 100. So solving for d1 and d2, we get d1 is equal to 100 times the tangent of 18.7 degrees. And we have d2 is equal to 100 times the tangent of 6.5 degrees. So then our height of the building is d1 plus d2, which is 100 tangent of 18.7 degrees plus 100 times the tangent of 6.5 degrees. So now that's calculator food. So 100 times the tangent of 18.7 plus 100 times the tangent of 6.5. And putting all of that together, we end up with the building being about 45 feet tall. Okay, so the next one is for you guys. So first of all, this one should really say you try. So the Americans with Disabilities Act states that the incline of a wheelchair ramp should be 14.5 degrees. If the ramp needs to reach a porch 4 feet above the ground, how long should the ramp be? All right, so let's go ahead and work on that. I'm going to break everybody up into groups. Alright, so I'm going to send everybody to some rooms, then I'll check in with you guys and see how you're working, how the U-try is working out for you. Alright, so since we know since we know the opposite and the hypotenuse, that says we should use our sine function. So setting it up, we have the sine of 14.5 equals 4 over our hypotenuse, which is x. Solving that for x, we get x is equal to 4 over the sine of 14.5 degrees. And we feed that to our calculator. So 4 over the sine of 14.5, and we get 15.97, so about 16 feet. All right, so now we need another definition, which is a bearing of the first type. So a bearing of the first type is always an acute angle measured from the north-south line. So if we make our cardinal directions, we have our north-south line, and we have east and west. So, for example, if I were to say north 45 degrees west, what I would have is I draw my north-south line, and then I'm going to measure an acute angle from north, and so north is up, and I am going to go west 45 degrees. So that would be north 45 degrees west. So you measure from the north-south line, and then you're going to move west 45 degrees from the north-south line. All right. Let's have you guys try one. So go ahead and draw south 30 degrees east. Alright, so once again we draw our north-south line, and this time we have south, and we're going to go 30 degrees to the east. And that would be our angle, so 30 degrees east of south. Alright. So here is our last example for today. So on the beach, lifeguard towers are approximately 250 meters apart. A lifeguard sights a boat in distress directly west of her location. At a tower directly north of her, the same boat is observed at south 86 degrees 25 minutes west. How far west is the boat from the tower? And let's draw our picture. So we have our first lifeguard tower, and then we have our second lifeguard tower, and we know that the distance between the towers is 250 meters. Then we have our boat out here, and then this is the distance we want. And then we know that from this tower, we have the measure of this angle is 86 degrees and 25 minutes. So based on our diagram, which trigonometric function is going to tell us about our distance that we want right here? Let's call it d. Well, we have our angles here, so that's opposite, and we know adjacent, so that's once again going to be tangent. So we have the tangent of 86 degrees 25 minutes is equal to opposite over adjacent, so d over 250. So solving that equation for d by multiplying both sides by 250 gives us that the distance is 250 times the tangent of 86 degrees and 25 minutes. So we grab our calculator and we start putting that in. So we have 250 times the tangent of 86 degrees and 25 minutes. So back into our angle menu again, we grab minutes, press enter, and we get 3,992 meters. So I'm going to say about 4,000 meters, which is about 4 kilometers. So that would be the distance to the boat.